In this video, we're going to talk about how to graph from an equation. First, we're going to do a reminder of our big overview where we're going with this unit. I'm going to remind you of the slope-intercept form, and then we're going to graph from slope-intercept form. Just a quick reminder of our big overview and the big ideas from this unit. A graph is a picture of all of the solutions to an equation. So it's really useful to graph them because then you can get more x's and y's that are solutions to the equation. It's also a picture of all of the inputs and outputs of a function. So keep in mind all those x's are inputs and all those y's are outputs of the function. And finally, and this is the most important piece of this page and of this video, is that in order to both graph a line and write the equation of a line, you need the location, a point, and the steepness, the slope of the line. So in this video, we're going to be talking about graphing a line. Every time you graph, you need a location. Where is that line on the graph? And then how steep is the line? Throughout the unit, we've been kind of covering a bunch of these. This is the one that we're covering today, and that is how to find the graph of an equation. And last part of the big overview to remind you of is that everything we're graphing is a linear equation. So, and all of this stuff only applies to linear equations. It only works because the rate of change is constant for a linear equation, that the slope is the same. So these rules only apply when your x has an exponent of 1, and you won't see an exponent on it because it has an exponent of 1. So now let's take a look at slope-intercept form again. So you'll remember that linear equations are frequently written in slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. Now let's do this. Okay, so we're going to graph from slope-intercept form. So you can see that this equation is already in slope-intercept form, y equals mx plus b. So remember our big idea, in order to graph, and a graph, we're going to picture all of the x's and y's that are a solution to this equation. In order to graph this, we need both the slope and the location, the steepness of this and the location. Let me write that. We need the steepness, which is the slope, and we need a point. So think about this for a second. What is the slope and what is the point? What information do you know from this? Well, you should know from the previous slide that m is 2/3, that that's the slope of the graph. And the point that we have here is the y-intercept. And the y-intercept is 0 and then whatever this number is, -5. Now, I've got my location and I've got my steepness. Now I'm ready to graph them. And the question is, which one, if you were telling somebody how to graph, which one makes the most sense to tell somebody first? If you're graphing a line, does it make sense to tell somebody the steepness of the line first or the location of the line? Hopefully you said the location of the line, because you got to know where it's going to be on the graph first before you know how steep it's going to be. And so this is our location. So we start with a y-intercept at 0, -5, which is right here. So we go down to -5, and then we do our slope. And hopefully you remember that slope is easy and fun. Just remember rise over run. So we're going to run 3. This is 0, 1, 2, 3. And then we're going to rise 1, 2. And that's going to be our next point on our graph. This is a solution to the graph. This is another solution to the graph, or to the equation. You can do it again too. 1, 2, 3, 1, 2. Remember, it's linear. We know it's linear because the exponent is 1. So the slope between any 2 points is going to be consistent. And then you want to draw a line. Notice how my line goes all the way through the graph and has arrows at both ends, because this line goes on forever and ever and ever. A lot of times you'll hear people say you start at the y-intercept, but the line doesn't actually start there. There is no starting or stopping point to the line. All right, let's take a look at another example. So can you identify the slope and the point that we're going to use in order to graph? The slope is the number in front of x, which is 3, and the point in this case is the y-intercept, 0, 1. And again, it makes more sense to plot the point first and then how steep it is than to do the steepness, and then you have to drag your line up and down to try to get it onto the point. So I'm going to go to 0, 1 and plot my point. That's my y-intercept. And then my slope is 3. So do I just go up 3, 1, 2, 3, and put a point there? Would that line have a slope of 3? No, that has an undefined slope. Do I run 3, 1, 2, 3? No, because that has a 0 slope. Maybe I run 3 and then I rise 3? No, because that would have a slope of 1 over 1. So what do? What you do is you write this as a fraction over 1. So 3 over 1 is the same thing as 3. And this is my run, and this is my rise. So I run 1, rise 3. Run 1, rise 3. 1, 2, 3. And then I draw my line. It's always, if it's not a fraction, stick it over 1. And draw a line all the way through the graph and put arrows on the both ends to indicate that it goes on forever. We're going to do one more. We're going to graph y equals negative x. So again, slope, negative 1. What's my point, though, here? My point, I don't have a y-intercept. I don't have a y-intercept. I could have put a plus 0 there, and I'm not changing the equation at all. My y-intercept is 0. My slope is negative now, so instead of running and rising, I'm going to run and sink. So still stick it over 1 because it's not a fraction, so I'm going to stick it over 1, and I'm going to run 1, sink 1, run 1, sink 1, so that I have a negative slope when I get done. And then, of course, I'm going to draw my line with arrows at both ends. And there you go. So hopefully you now know how to graph from Slope-Intercept Form.